Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, I hope you can see how excited I am, and I want to transfer the excitement to you people. I want to welcome you to this session of TV learning. The next 30 minutes will be intensively for learning physics, and I want you to join me. I am teacher JB, your physics teacher, and I want to welcome senior ones for this lesson of today. And senior ones, if you remember, we have gone, quite a mile, a distance together. We have been going through concepts that some of you thought were difficult, but I want to believe you are finding them comfortable. And so today, we are going to introduce a brand new unit. That's why I've got a brand new excitement, right? And so we are going to have a brand new unit. And I like number 6. And so we are going to have a brand new unit 6, which is talking about what? Work, energy, and power. Maybe I should talk about it differently. Work, then energy, okay? Energy. Wherever you are, try to demonstrate some energy. And power. Maybe we have been speaking about these words, we didn't know what they mean in physics, right? Maybe you just got the words from the dictionary, or you heard it on the news, or you read it from a newspaper, or a magazine, or from a friend. But today we want to look at the meaning of these words. Work, okay, energy, and power in physics. So that is our brand new unit, which is unit 6. And so the key unit competence is that by the end of this unit, you should be able to analyze the process of energy transformation. So you see, there's that word on your screen, transformation. You see this word? Kind of a big word, right? Energy transformation and conservation. So those are big words. Transformation and conservation. Big words. But they will be simplified. If you want to know what those words mean and many other concepts in work, energy, and power, never miss a single lesson. We shall discover all these concepts. And so our lesson 1 today is about work. And our objectives, as you can see from your screen, we have 3 small objectives, but they are very important, okay? Small, but important. Just like you students of Senior 1, you are small people, but very important people. And so the first one, we should be able to define and explain the term work as applied in physics, okay? Then 2, we should derive the formula for work. So after understanding what work means in physics, now we need a formula to allow us to calculate the quantity, which is called work. And C, we should use the relation W equals F times D to solve numerical problems. And we shall see that that's the formula that we shall use for finding the amount of work. And all those that I've said are here on the board so that you are able to refer to this as we go through the lesson. Right. Let's move to the next slide there. So your outline for this unit 6 is going to look like this. We shall talk about forms of energy. We shall talk about transformation of kinetic energy into potential energy and vice versa. When they say vice versa, that is a new word also to you, right? Vice versa. Vice versa means the reverse is true. For instance, if I say, I learn from you, the teacher says, I learn from you, and vice versa. So you reverse the trend. It means you learn from me. That's what it means. Then we should look at sources of energy also, and different ways to conserve energy, and law of conservation of mechanical energy. Good. Now it is time to test your memory. what you learned before. Let's test our memory with those questions you are seeing on the screen. 1, what is force? Think about it. Okay? Test your memory. What is force? And why am I asking these questions? Because they are important for us to be able to understand work, energy, and power. So what is force? Do you remember the definition of force? There are so many definitions of force, but we can get any. Like, let me give you one. So force is a quantity which changes a body's state of rest or uniform what? Uniform motion. That's the meaning of force. So if a body has been at rest and then the body begins to move, then we say there is force. Okay? So it is a quantity. A quantity means we can measure it. We can quantify it. So it is a quantity which changes a body's state of rest or uniform motion. Right? So if you come with me to this trolley, I hope you are looking at this trolley. Okay? So if you come with me to this trolley right now can be said to be at rest because it's not moving. So the trolley is at rest. Now, if I apply a push or a pull, a push means this. Okay, let's just try to push it a little bit. Do you see what is happening to the trolley? I just pushed it a little bit. You see what is happening? The trolley is moving. So because the trolley is moving, it means the body's state of rest has been what? Changed. And if a trolley has been moving, for instance, now it is moving, and I apply a force here, then the trolley can stop. Okay, like this, I apply a force, it stops. I move it, it is moving, I apply a force, it stops. It is at rest, if I apply a force, it begins to move. So what is making the trolley to stop and move? We call that force. Okay, testing your memory, remember? We go to part B. Part B says, what is the SI unit of force? Very easy. The SI unit of force is the what? Is the Newton. And the Newton is abbreviated as capital N. Don't use small n. You small boys and girls of senior 1, you might want to use small n, like the way you are small. No, use capital N. C, define this unit. So how do we define the unit? Remember the unit is a Newton. So how do we define the Newton? So we say the Newton is a force which causes a body of mass, how many kilograms? 1 kilogram, to accelerate at 1 meter per second squared. So it means when you apply a force of 1 Newton to a body whose mass is 1 kilogram, the body then begins to speed up. It begins to move, okay, with an increasing speed. It begins to speed up. And the acceleration is going to be 1 meter per second squared. So that's the meaning, that's the definition of the Newton. And lastly, what instrument do we use to measure force? The instrument that we use to measure force, that is part D, the instrument that we use to measure force is called the Newton meter. We call it a Newton meter. Now, some people can also call it a spring what? A spring balance. And right here, we have got a spring balance. They come in different shapes and sizes and designs, but this is one of them. Maybe you have never seen one before, but this is a spring balance. We can call it a Newton meter. So as we go through this lesson, we shall also see how a Newton meter is used. We shall come back to this, okay? So don't worry. All right. So we have finished testing our memory. Now we are so good to begin. Work. Look at what you have on your screen. Work. If I ask you, why are you at school? Many of you will say, I am at school because I want to acquire knowledge. I have good friends, very good friends, who are recording this lesson right now. They are my good friends. They went to school. Now they are recording the lesson. Beautiful job, isn't it? It is. That is work. If you look at the screen, you will even see like this. These are engineers, mechanical engineers. They are trying to repair some parts of the machine, which may not be working very well. That's their work, to maintain it. That is work. Maybe some of your parents are also mechanical engineers. Beautiful, right? You have got this. These are builders, okay? They are trying to construct a structure. That is work. You can see some students in the background. Perhaps these students are interested in getting a work related to construction, which is beautiful also. If you continue reading, studying very well, you'll achieve that. Okay? You have got this. You see these guys here? They are working on some complicated machines. Right now, you cannot do it, but I'm very sure if you continue studying a lot of physics and other subjects, seriously, you may be one of these. Very possible. And a country like Rwanda, our country needs people like you, to study and then push our country to the next level because we are relying on you. Okay? The young people, you can do this. Then you have got also this group of students and some friends of theirs who are handling holes. They are digging. Isn't that work also? Yes, that is work. Again, if you look at this, where the icon is, there is a mouse. See, here. Just like this. Even me right now, I'm doing work. Okay, so all those and so many others, I've not been able to bring for you all, but you know all the other different kinds of work. Just think about it. You are riding a motor, that is work. You are a driver, that is work. And so on and so forth. Okay? Now, in physics, there's a different way that we define work. Okay? There's a different way that we define work. All this that we have seen is everyday expression of work. But in physics, work is defined in quite a different way. And that is what we want to look at. Okay? I got a beautiful photo for you here, a picture, which I think, if you look at it very well, you will always remember the definition of work. Let's try to talk about it together. Okay? Let's go to the screen. And I hope you are going to read it along with me. When you say something, you can remember it. When you do it, then it gets stuck into your memory. Okay? So we are going to talk about it here. When you get some free time, please go and try to practice doing work at home. You'll never forget the concept. So let's read this together. Work is only said to be done if the point of application of a force moves through a certain what? Distance. In the direction of the what? Of the force. Let's think about that. Work is only said to be done when the point of application of the force moves through a certain distance in the direction of the force. Think about that. Me, I'm going to capture what I think is, what I'm sure is the main point. I'm going to capture it here as you keep thinking about that. Okay? and keep reading about, reading the idea that we have written on the screen. Me, I just want to capture the main idea, which I have understood from that statement. Maybe you are also capturing an idea from there. Okay? Then we compare the two. For me, the summary, I have seen the word work there, which I think is important. Work. Then, I have also seen a quantity called what? Force. Let's look for force. Me, I've already found my force. It is here. Are you guys able to see force? It is here. Work is there. Me, I'm seeing force. Then, I'm also looking at this, moving through a certain distance. This is something I can measure. It's a quantity I can measure. So I'm picking them out. Work is a quantity, I've picked it out. Force is a quantity, I've picked it out. And distance is another quantity. So I'm also going to have distance. Okay? So what does it mean then? I will say work is equal to force, then times distance. That's a beautiful formula. Never forget it. Even when you go to the university, some of you are going to become engineers, as we have said. I think we agreed about that. You will need to remember that formula. Oh, someone says, most of you are going to become teachers like myself. That will be a blessing, because teachers drive the nation. Very good. Teachers drive the nation. We are the ones who drive the nation. So beautiful if you become teachers. Great. So work is equal to force times distance. Let's use symbols. What symbol do we use for work? The symbol we use for work is W. What symbol do we use for force? It is F. And what symbol do we use for distance? It is D. Again, you have to be careful here. Some people don't like D. Me, I like D. But some people don't like D. So in other cases, let me use another beautiful color. Some people, instead of using this, they also say W is equal to F times X. Do we blame them? No. Because their X is standing for what? Distance. And F is standing for force. And W is standing for work. So for now, let us use this one. So W is equal to F times D. But if you find someone using this, don't cry. Don't begin complaining, as long as he or she has defined X as being a what? A distance. And F as being force. And W as being work. Okay. So far, so good. Now, what is the unit of force? That's why we tested ourselves. Remember, what is the unit of force? The unit of force is Newton. What is the unit of distance? This one is very easy. The unit of distance is what? Meter. So, what does it tell us? This one gives us a way of getting the SI unit of what? Work. So, the SI unit of work, as we are going to introduce, is called the joule, which is J, joule. And I'm going to write it down for you. J is joule. Joule. You can even use my initials to remember joule. My initial is JB. Now this is joule. You see? My name agrees with physics. Wonderful. Okay, so this is a joule. Now, 1 joule is equal to 1 Newton times meter. Because remember, force is Newton and distance is meter. So it means 1 joule is 1 Newton meter. So this is also a very important concept. And we shall come back to this, no problem. So the key thing we have talked about here, okay, looking at our learning objectives, we have been able to define work, because we are saying work is the product of force and what? Distance. Work is force times. We have been able to do that. Then, we are also able to state the SI unit. Now, you senior ones, you might think this is senior 1 unit. No. not senior 1 unit. It is SI unit, and it is in French. In English, it is International System of Units. In French, I know a lot of French. It is called Système International. If I made a mistake, please, you can ring me up and then tell me the correct pronunciation. But I believe it is called Système International. So it is SI unit. Don't say senior 1 unit. So we have been able also to see the SI unit of work, which is the what? You have not said it. Which is the joule. Very good. And we abbreviate it using capital J. We have also been able to derive, not use, we have not yet used, but we have been able to derive the formula W is equal to F times D. And again, we also said some people may use W is equal to F times X, as long as you define what D or X is, no problem. Now, can we then use this formula to solve some numerical problems? Yes, we are going to give it a try. But before we give it a try, tell me, I'm going to perform some demonstrations here, and tell me whether I am doing work. Remember my formula, and again you can go back to the screen. Actually, let's go back to the screen. On the screen we are saying, work is only said to be done if the point of application of the work, of the force, moves through a certain distance in the direction of the force. Good. Me, I like playing football. I know you also play football. Girls, you play football also as well, because there's football for girls as well. And volleyball and basketball and so many other sports. Now, if you kick a ball, does the ball go in the opposite direction? I have never seen that. When you kick the ball goes in the direction of the force. So I want you to tell me, am I doing work here? Okay? 1. Observe what I'm going to do. 1. You'll tell me whether I'm doing work. I'm pushing the wall. And I'm sweating, by the way. I'm using a lot of energy, a lot of force. I'm pushing the wall. A lot of energy. I told you I'm very strong. Am I doing work? No. Some people say I'm not doing work. Why? Because the wall has not moved an inch. It has not moved a single distance. So I have not done work. Let me try again. You might think I'm weak. You might think I'm weak. I've got some work here to be done. Slotted masses. I'm going to attach it to our spring balance. Remember the name of this? Spring balance. And if you can focus on this, I just want you to focus on this scale, okay? Tell me if you have seen the scale very well. I will wait until you tell me you are seeing it very well. Okay. People are telling me they are seeing the scale very well. Now, if you look at this scale, there's this writing which is newtons. What does it mean? It means we can use this device to measure force, because the SI unit of force is newtons. All right, so let me entangle this hook on this mass. And because I want you to see it very well, allow me transfer my trolley so that you can be able to see it very well. I'm going to keep my trolley nicely here. Okay, this is great. Look at what is happening. The pointer is the white mark you are seeing inside there. That's the pointer. Right now, what is the pointer saying? 0. Am I applying any force? No. When I begin to apply the force, will the pointer remain at 0? No. The pointer is going to move, showing me that I'm applying some force. But remember the question I asked you, tell me whether I'm doing some work. Okay, let's try and see. Is the pointer still at 0? You need to look at it and tell me. Is it still at 0? No, but I'm already applying some what? Some force. Let me continue pulling. Is the pointer still at 0? No, I'm applying a force. According to this, it is more than 1.25 newtons. But is our load moving? Not moving. So at this point, am I doing work? Physics tells me I am not doing work. Let me continue increasing the force, and then we see what happens. Okay, I'm now increasing the force. Is anything happening? Yes. Now the body is doing what? Moving. And because the body is moving, then I can say I am now doing work. And if I want to get the amount of work I have done, I will then measure the force. That means I would read the pointer, read the scale. I get the force, then also with my beautiful meter rule, which is this one, nice meter rule, I measure the distance that the force has moved through. If I multiply those two, then I get work done. So, have we done the work? Yes. I'm not meaning the other work of physics. Have we done the work of going through our learning objectives? Yes, we have done that work. Have I done this work in physics? Yes. So work is said to be done in physics when the point of application moves through a certain distance. And so this was our introduction to this Unit 6. And I know you are going to enjoy this Unit 6 because all the concepts that we need to understand this Unit 6, we have looked at them. And I want to believe you have understood them. And so just remember here, if for instance, the force applied is 1.25 newtons, so we shall say work done is 1.25. If the distance covered is 50 centimeters, then it means we will convert that into meters. Converting into meters means we divide it by 100. So when you multiply this, then of course that 0 cancels. This is 1 and that is 2. So we remain with 1.25. Divide it by what? By 2. And the amount of work done you are going to find will be in joules, which you can also say, either you can use joules or you can also use Newton what? Newton meter. So that is how we apply the formula W is equal to FD in numerical, to solve numerical problems. So as you can predict, in our next lesson, we shall have so many numerical problems, which will require us to use this wonderful formula. So I want to thank you so much, my dear students, for being attentive. I know you have been taking your notes, and I want to pray that you have been understanding these concepts because they are going to be helpful. So many people are already telling me, yes, they have been understanding. So thank you so much. Stay safe until we meet again for the next lesson. Bye-bye.